Okay, here's how the wave equation kind of works. Let's say you're standing looking out at a lake, or maybe you're on a boat watching this happen. And as you watch waves go across the lake, you notice that they're moving at a speed of 3 meters per second. So if a wave started right beside you, 1 second later that wave is 3 meters away, then the next second it's 6 meters away. So it's literally how quick those ripples are propagating or traveling across the water. And as you stand and look at them, you notice that they have a wavelength of 2 meters. So maybe if you took a picture, water waves look like this. There's one. Let's draw a second one. If you took a picture of it, the wavelength, which would be the distance from here all the way to there, you measure it to be 2 meters. Notice that wavelength could also be like crest to crest. That would be 2 meters. Or trough to trough, that would be 2 meters. There's all sorts of different ways to measure the wavelength. It's just the length of one full wave. Now what the wave equation says is that the speed of a wave is connected to the frequency in the wavelength by v equals f lambda. If you know that it's moving at a speed of 3, I'm going to put the units in, 3 meters per second. We don't know the f, but if we know that the lambda is 2 meters, then you don't have to put the units in. I'm just doing it to show you how they work out. F all by itself is the 3 meters per second divided by the 2 meters. Number-wise, 3 divided by 2 is 1.5. Unit-wise, the meters of meters per second cancels with the meters down there. So we end up with 1.5 per second, which is a funny unit. So it could be seconds on the denominator, or it was named after a guy that did a lot of work on waves called Hertz. So the frequency would be 1.5 hertz. That's how the wave equation works. If I give you 2 out of those things, you should be able to do the math to figure out the third.